Hello, students. We are looking at, see here, 4.1 homework. So the assigned problems are 1 through 12, 14. Let me zoom in a little bit here. There we go. 1 through 12, 14, 16, and 20 to 21. So let's take a look at those problems and see how they kind of address what we're looking at. So can you multiply an odd number by 2, add 1? Is your answer even or odd? Okay, so again, talking about even and oddness. For these, I would recommend even starting with a general term from this. So if it says an odd number, remember, don't just pick an odd number. It's okay to start like that, but try to get to the point where you start to generalize. So you can say any odd number kind of looks like this, right? And then do what it says, multiply it by 2. When you get that result, then add 1. Is that result even or odd? Okay, even numbers, multiples of 2. Odd numbers are 1 more than a multiple of 2, or 1 less than a multiple of 2. Okay, so let's see here. What else we have here? Classify statements as true or false. 5 is a divisor. So these are just factual statements. You have to tell whether it's true or false. Thinking about the terminology, multiple, divisor. They don't have one on factor, but for example here, the word divisor and the word factor are interchangeable. So you might see your textbook when you're teaching say that 5 is a factor of 20. Okay. All right, let's see here. Without using a calculator, test for divisibility. So remember, now we're going to use our divisibility rules. So we know our test for 2 and 5 and 10 is to check the last digit. For 4, and honestly 4 and 25, but they don't have that one listed. 4 is the last 2 digits, 8 is the last 3 digits. But that's how we get those. But don't forget when we just kind of talked about as well, if you watch the videos, we've got the 3 and the 9. That's where you add the digits up. So that one is a little bit different. And that just leaves us with 6 and 11. Now 11 is similar to 3 and 9. Instead of adding all the digits up, you add up every other digit, put the number, kind of put that sum on top, add the other digits that you didn't add, put the sum on the bottom, and you find the difference. So this is kind of a weird one. I'll put that one in a cloud. 11's a little bit strange. But then 6. So 6 is fantastic because you don't need a new rule to test for 6 because 6 is equal to 2 times 3. So if 2 works and 3 works, and because they are what we call relatively prime, they have no factors in common, then it's guaranteed to be divisible by 6 as well. Okay. So yeah, just asking you to kind of check a few of those. Let's see, you're using divisibility tests. 9 friends win the lottery. Here's the payoff. Can it be equally divided? All right, well, use your test for 9 into 4 sections for the next one. Test for 4. Okay, it's just saying, can it be divided? It doesn't ask you how many times. Then find all possible single digits that can be placed in here so that this number is divisible by 2, 4, 9, 3. So you're kind of filling in a blank space. And I do enjoy questions like this. I think a question like this on an exam would be kind of a good one to make sure that you understand and can explain the different tests that you might be using. Okay. Let's continue on. So what is it, 1 through 12? Okay, well, that's 1 through 5. Let's see here. Jump to the next page. Without using a calculator, tell whether it divides or does not divide, whether it's true or false. So again, as you're looking, it's a great idea to say, can I see factors? If it's already factored, that's even quicker for you. If it's not factored, remember some of your theorems that we talked about, the things that we can do, where, for example, in this one, we're looking at, let's see here, maybe I'll do a different number because I don't want to do that exact problem for you so you can kind of practice it yourself. Let's say, what if I did 3 goes into 4222, and for some reason you forgot the idea, what does 3 represent? So you could break the 4222 into 3000 plus 1222, and then the 1222 becomes 1200 plus 22. So yes, 3 goes into 3000, it goes into 1200. Does 3 divide here? The answer is no. So you would say that 3 does not divide 4222. Okay. And you do the same thing for 7. Now it says justify the statement. So now it is saying it's giving you a statement that is true and you have to provide justification. So very similar to what you were just doing, just have to provide why is this one true. Mentally classify each of the following as true or false and justify your answers. So again, true or false, but these are mentally now. So be looking for those big components. Like, does 12 go into 24? Yes. So kind of think of splitting it up mentally, like I was just showing. Classify these as true or false, assuming A, B, and C are whole numbers. So when you get down to parts C and D, it's hey, these are whole numbers. And let's see here. Is this divisible by 12? Is this divisible by 12? Those look very similar to these up here. Answer the questions without performing the division. Explain how you did it. So we've got some problems that are kind of somewhat similar here. Questions 8 and question 10, they look fairly similar. 24013 divided by 12. The question is now, is it divisible by 12? So the wording might change a little bit, but the concept will be the same. Let's see here. Bookstore marked notepads down from $2, kept the price over $1. It sold all of them. Okay, so you have some notepads. The total amount from the sale was $31.45. How many notepads were sold? Oh, okay. So we have two numbers here, right? How much was a notepad and how many did I sell? So you have two numbers being multiplied. So take an opportunity to break 31.45 down into factors. What are the different factors? And then try to see if you can tell from that, you need one of them to be between $1 and $2. Right. So then kind of see, is there one of those pairs that would work out really nicely? Okay. Let's see here. So 13 was out. What else did I say? 14, 16, and 20 to 21. So 14 classify as true or false. These are great questions. These are if-then statements. Definitely going to have some like this. Probably on the exam. They kind of test your ability to understand what is divisibility. If a number is divisible by 6, does that mean it's divisible by 2 and 3? If it's divisible by 2 and 3, does that make it divisible by 6? So it's going forwards and backwards with conditional statements. Remember, if you want to prove a conditional statement is false, so this is like this kind of statement, it's an if-then statement, you need to make sure the first one is true and the last one is false. If this occurs, then the whole statement would be considered false. Okay, so a little bit of a refresher there from chapter 2. Let's see here, 14, 16, if 28 divides n, what other whole numbers divide n? So that's a really good idea because again, now whatever you have is a multiple of 28. What must divide it? And then 20 to 21. So this one says prove the test for 9 for any 4-digit number. This is fantastic. I did one in the video for a 3-digit number. And so just remember, when you're doing it for a 4-digit number, make sure you are actually thinking of a 4-digit number in general. So you want to use something like A, B, C, D in place value form, which would be A times 1,000 plus B times 100 plus C times 10 plus D. So that's when it says prove the divisibility test for any 4-digit number, you want to use the variables so that you cover every single case. And lastly, what digit is A? Ooh, so here's an A and an A here, and you want it to be divisible by 9. So use your divisibility test for 9 and then see if you can figure out, well, what number does that have to be to make this work out? All right, so that's the big idea in the homework. Let's see if I go back to part A. Was there any of those? Okay, what 5-digit? Yeah, I guess I could do something like this one. Here, I'll do the one in part A. 5-digit number is divisible by 9. What digit does A represent? So go back and say, what's the test for 9? Well, let's see here. The test for 9 is the sum of the digits. So A plus 2 plus 4 plus 8. Okay, so 2 plus 8 is 10 plus 4 is 14, and A plus A is 2A. So I have 2A plus 14. And now I need it to be divisible by 9. So yeah, 9 doesn't go into 14 evenly. The next values, so above 14, think of multiples of 9. Multiples of 9, so 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Okay, so if I've already used up 14, take away the 14, and that's going to leave you with 4. Take away the 14, and it leaves you with 13. Take away the 14, and it leaves you with 22. So what you're looking at then is this 2A. 2A could equal 4. 2A could equal 13. And 2A could equal 22. So from the first one, you'd be able to say, well, A must be the number 2. So that's possible. For the second one, A would have to be the number 6.5. But you can't have a single digit represent 6.5. So we have to toss that one. And the last one would say A is equal to 11, which is great, but A is a single digit. So I got to cross that one off. So it turns out here, there's only one number that's going to work and make that entire thing divisible by 9. Very cool. I'll hit the MCs next. That's it for now. All right, off you go.